talking about relations and functions today. We just figured out that we did really well on the last chapter test. Everybody give yourselves some props for how well you did on the last chapter test. Yay, you guys did awesome. This is really close. Okay. So, here we go. We're starting a very easy chapter, and it's on relations and functions. So let's first talk about what a relation is. Anybody remember what a relation is? We all did this in Algebra 1, believe it or not. This is not brand new information. That they're related. Okay. A relation is a set of ordered pairs. We suddenly remember. Okay. Ordered pairs. Okay. So, in other words, we can have something that looks like this. -3, 4. This would be a relation. We have a set of ordered pairs there. So a bunch of them combined. All right, so within a relation, domain. What's a domain? You have two choices. It's either the x values or the y values. Unger. What?
Never mind.
Never mind, okay.
I thought it was something totally else.
Okay. Domain is either x or y. So you guys tell me, what do we think? The other one is called the range. So, okay. Aun, is that how you pronounce it? Aun. Okay, go ahead. Aun.
I'm guessing X.
Okay, everybody zip it. Shh. Yes. Give it up for Aun. Okay. Next. That is like ridiculously close. Okay. It's all set up normal. It's not. I don't think. It's okay, I'll fix it later.
What are you doing?
All right, range. I'm looking at the setup. Range. Ah, that's good. Okay, so let's see. RAM. Excellent. Give it up for RAM. Hey. Okay, a function. Function. Let's see. So a function, Matson Bose. Shh. You can. You can plug something in to a function. True. Good. Maxie?
Is that the x and y value? I mean, like in a...
So, okay. Yeah, so this is kind of broad. Okay, Unger, go ahead.
It's the it's the formula that puts out the x and y values, right? You can plug
Okay.
numbers into.
Okay. So it's a, I'm going to put that in quotations, a formula. Everybody give it up for Matson Bose, Maxie, and Unger. Yay! Formula that pairs the x and the y, or let's say x and y, or another way of saying it, it relates the x to the y. Now, the thing about, right, so the actual definition. So it's when every member of the domain is paired with exactly one member of the range. So every member, yes, vertical line test, yeah. So,
That was horrible.
they're not bad. I don't know why everybody thinks they're so awful. They're not. They're not. I promise. You guys will see. I'll show you. Well, okay. Let's just keep going. Okay. Every member of the domain is paired with exactly one member of the range. Okay. So, all right, so we're getting kind of low here. All right, and then, like you all just very enthusiastically reminded me, the vertical line test is one way to test whether you have a function or not. Okay, so the vertical line test, when you have a graph, that's one way that you can test whether you have an actual function or not. What's up, Salmon? Okay, no roller coaster rides in here, so back. Okay, although, did I tell you all that one of the reasons I wanted to be an engineer was so that I could design roller coasters for a living?
Do that?
You can do that, yeah. There's a profession called a Disneyland Imagineer, where they design roller coasters for a living. So I wanted to do that, and then when I got to Berkeley, I was taking all the upper division engineering classes, and I took one called Mechanical Engineering 104, where everything started to move, like, in the problems. And I was like, yeah, this is not working for me. Like, I literally would look, they have boards that move all over the place. There were all these Greek symbols up there, and I got through with my C-, and I was like, all right, things that stand still, that's for me. So that's what I did. And then I decided to teach, obviously. All right, so here we go. Yes, it is. It is. I couldn't quite get used to, the engineering profession was sitting at a very large desk doing calculations all day. And you're very isolated. You're on your own. Every now and then you get to call, like, the mechanical engineers or, like, the architects and talk to them. Sometimes you get to go out to sites and whatnot, but this was not for me. What? Yes. Yes.
That's your entire life.
Okay, here we go. Small desk and I know. Yeah, believe me, my mother was trying to convince me to stay in the engineering profession. She's a very feministic type of a woman and was loving the whole engineering daughter thing. But whatever, that's okay. All right, 4, 5, 5, 4. We are stating the domain and the range here. 4, -5, and 5, -4. That's a lot of 4s and 5s, I agree. All right, so stating the domain and range, super easy. If we look back to what we defined the domain to be, domain is all of the which ones again? Shout it out. X's. And the range is all of the Y's. All right, so the domain. Who can tell me what the domain is? And you do not have to repeat them if you want. Okay, Garcia. 4 and anything else? 4 and 5. All right, everybody give it up for Garcia. Yay. Okay. Now, you might be looking at this and going, okay, 4, 5, 4, 5. You don't have to, there's 4 there, and then there's 5, and that's it. You don't have to repeat them. Okay, so can somebody tell me what the range is? Okay. Let's see. Lumaquin. All right, everybody give it up for Lumaquin. Enthusiasm here is awesome. Okay. Do we need to do another one of those, or are you guys good? Cool.
I think we need to do another.
Underhill, do we need to do another one for you?
Yeah.
Underhill. Find the range of each relation. Yeah, I think you guys are going to like tonight's homework. It's really easy. Find the range of each relation for the given domain. What is crackling back there?
Oh, wait.
Not
Oh, wait, yeah. There's something, I can hear it sounds like a chip bag.
Dun, dun, dun.
Everyone knows that witches sound like
Witches sound like chip bags. I like that. Okay. All right. So, in this first one, whoops, sorry about that. Okay, find the range of each relation for the domain. So, this first one, we are given a function of y equals 3 plus 2x, and we want to find the range for a domain of 0, 3, and 7. So these are 3 separate ones. So in other words, if the domain, if we had a 0 for a domain, and remember, domain represents the x coordinates. If we had a 0, what would the y be to go with the 0? If we had a 3 as the x, what would the y be to go with the 3? And so on. So, can someone start me out on this? We don't, yeah, and let's try not to make it complicated. Finerman. Is it Finerman or Finnerman? Finerman. Okay, go ahead.
Would you plug in the domain?
Yep. So let's start with 0. Where am I plugging in 0?
3 plus 2 times.
Good. Okay, so everybody give it up for Finerman. Yay. Okay. What is, everybody, let's shout this out. Ready? 2 times 0?
0.
Plus 3? 3. Cool. Okay, so that's the first one. Now, what do I do next? So now we just found the domain when, or sorry, the range when the domain is 0. Now what? Okay, Matson Bose. Good. Redo it with the 3. So what does that mean exactly? Redo it with the 3. Plug the 3 in for what? For x. All right, everybody give it up for Matson Bose. How about a little more enthusiasm? That's better. Okay, ready? Everybody shout it out. What is 2 times 3?
6.
6 plus 3?
9.
All right, nice. All right, okay. Last one. Last one. What do I plug in for the last one? O'Brien.
7.
7. Excellent. So it's 3 plus 2 times 7. All right, ready? Everybody, what is 2 times 7?
14.
And 14 plus 3? 17. Okay, cool. Do we need to go through another one of those?
Thank you.
No, thank you. Oh, I like the polite. Okay, questions on this? No, good. All right. Here we go.
Is that it?
Almost. Yes, for that one. All right, here we go. Now we have pictures involved, sort of. Okay. Determine, as I call it, determine whether each mapping, oh my, okay, whether each mapping, I'm starting to get more sleep now, so the energy is coming back slowly but surely. I know you are all very excited about that. All right, represents a function. Okay, everybody exhibit. Shh. Represents a function. And give a reason why. Oh my goodness. They are protesting. There may be writing involved in this math
Can
problem.
we just write because?
Yeah.
Can you just write because?
Yes. Because.
No. Or because I said so. No, you
Why
cannot.
not?
Can we say buffalo, 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 buffalo? That's actually a grammatically correct statement.
Interesting. Yeah, that is
Could you
interesting.
repeat that, please? 'Cause I
Buffalo,
believe-
buffalo, 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 buffalo.
We all better be multitasking right now.
Can you add 7?
Because buffalo is a
Yes.
place, it's a noun, and it's a verb.
All right, here we go. Shh.
Buffalo something else, like beating someone.
Marcy, I'm going to have you come up and explain that in a minute.
Yeah.
We hear, so the debate that we're having is buffalo, buffalo, buffalo is a grammatically correct, you're saying sentence?
7 of those buffaloes.
7 buffaloes?
I knew 7 would fit in
All
somewhere.
right,
guys.
folks, we will see this at the end, but we need to get through our math first. All right, everybody write these down. 1, 6, 11, so we have pictures, maps. This is a map, okay. And what this, all right, so I will go through and explain. I'm going to put 2 of these up here to start out with. Everybody exhibit. Shh. -3, -2, and 5, and 11, 12, 13. Yes, it's a -7. Okay, so now let's draw some arrows. Arrows. All right, so let me go ahead and copy these on the right-hand side, and then we'll kind of work through them. So we want to figure out which of these represents a function and which does not. Or maybe they both do, or maybe they both don't. I don't know, we'll find out. -7. And this other one. Underhill, you writing this down?
I already wrote it.
Good. You want to volunteer to do one of them?
No. Thank you.
Again, with the polite. That's good, polite. All right. So, remember what we said, functions. Every member of the domain is paired with one member of the range, okay? Now, what each of these circles represents, this represents the domain, and this represents the range for each of these. Okay, so what we're looking for, domain and range, and we're going to see this graphically in just a second as well, but what we're looking for is, are each of the x values, or the domain, do they only have one y value associated with them? Okay, so in this first one, does this one have only one y value that it's pointing to? Okay, how about the 6? And how about the 11? Yes, so this one would be a function because there is, okay, each x has only one y. Does that make sense to you guys?
Yeah.
Okay. No, you can't just say it's obvious or because I said so. Okay, now, domain and range for the second one. You guys tell me, what do you think? No. Okay, they all agree.
No one has too many
All right,
arrows.
Clark, go for it.
Because -2 is pointing to 2.
Right, the -2 is pointing to 2 separate range or y values. Okay, we're going to see this graphically in just a second as well. Okay, so in this one, -2 has 2 y values, so that would not be a function. Y values. Whoops. Okay. Questions on this? Can I switch the paper? Are you all good? All right. Now we're moving to everybody's favorite, the vertical line test. Okay. Here we go. Determine whether each is a function. So we'll go through a couple of these so you can see the difference. A function. All right. So here we go. We're going to make, so do not make these really detailed graphs. They are literally drawing really, really quickly. Okay, so I'm going to put 4 of them up here. And they will take literally like 10 seconds to go through each. They're really, really short. So x, y, label your x and y axes. All right, and now I'm going to put up what the graphs are. I am actually going to copy them on the other side of the line, which is probably going to be really annoying to all of you, but that's okay. Can you just what?
Blame Jonah.
Can you blame Jonah?
Like when all the like when it asks why, it's Jonah's fault.
Why should it be Jonah's fault?
Just because it's Jonah.
Just because it's Jonah. How nice. I'm sure he really appreciates that.
He doesn't mind.
He doesn't mind. All right, everybody is multitasking. We better be multitasking. So draw these on here. Everybody draw them, and then we will discuss.
Oh, they almost spelled things.
Okay, here we go.
North, south, southward.
All right, everybody stop talking. All right, vertical line test. Vertical line test. You are literally, so I actually don't know how Miss Barnett teaches this, but you can either drag a line across vertically. Vertical is this way. Okay, so what you're doing is, if you draw a vertical line through any part of this graph, are there any points that are directly on top of each other? You guys tell me.
Yeah.
This one is a no, so that means this is a function. Okay, now. Oh, beep, beep, beep. Okay, okay. Okay. So how about in this one? Okay. Is this a function or no? No. Who can explain why this is not a function? Alexander. Okay, oh, that's good. The y-axis, true. So, and if we drew one that was also right next to it, we would have 1, 2, 3 points directly on top of each other. Okay, how about the next one?
Yeah.
Driga? Did I pronounce that right? Okay. Good. This is a function because, again, if you were to draw a vertical line, none would overlap. All right, can somebody tell me about the last one? Let's see. There's one last one. Sambajon? Is that how you pronounce it? Sambajon. Go for it. No, because if you draw a vertical line, there are points that are directly on top of each other. All right, everybody give it up for everybody who just helped with that problem.
Yeah, you're amazing, guys. I love you all.
Okay, now, do we have the gist of this?
Yes.
Do we want to go through any more examples?
Not really.
Not really. How do you really feel? Just kidding. Okay, here we go. So, this is homework number 22. 62, written exercises. Yes, today is extra credit. All right, everybody get going.